Hi dear students, welcome to our channel Maths with Panindra. In this video we are discussing about operations on sets. In this operations of sets we have different category. So first one is union of sets. This is the first category. Second one, intersection of sets. Third one, difference of sets. First one union, second one intersection, third one difference of sets. Based on difference of sets, another important concept is there, that is a symmetric difference. This will play a very important role in competitive exams, dear students, like JEE symmetric difference of two sets. Okay, let us have a discussion one by one. Union of sets. What is the meaning of union of sets? Let A and B be two sets, then the union of A and B, is denoted by is the set of all elements, those elements which are either in A or in B, or in both A and B. This is the meaning of A union B. This we can represent it as, that is we can write it as like this: A union B is equal to X such that X belongs to A or X belongs to B. So A union B means X such that X belongs to A or X belongs to B. We'll consider some examples. Let example 1, let A equal to some set, we can take it like -1, -3, -5, 0. This is A set, and the set B equal to -1, 0, 3, 5. Then A union B equal to, so according to the definition, what the set of all those elements which are either in A or B or in both. So simultaneously we'll write it all the elements. So first -5, next -3, next -1, next 0, okay, next 3, 5. we cannot write 0 twice. Why? Because in set theory, repetition is not allowed. I hope you understand, your students. Okay, that is the reason we are not mentioning. Let us consider another example by taking different sets. Okay, let A equal to set of all x such that 5 is less than or equal to 5x is less than 25 and x belongs to n. This is one set, and b equal to x such that 5 is less than or equal to 10x is less than or equal to 20 and x belongs to n, and x belongs to n. Then A union B. Then A union B. Question mark. See, first find out x belongs to n. That means A set will write it first. X is equal to 1, substitute here. We will get x is equal to 1 means 5 is less than or equal to 5. There is no meaning. 5 equal to 5 will come. So, A set. X is equal to 2, substitute 10 will come. So, first 5 also will come. Why? Because x is equal to 1, n is equal to x belongs to n. So, n is equal to 1 if we substitute, x is equal to 1 substitute, 5 will come. 2 will come. 2 means 10. 3 means 15. 4 means 20. In first set, that only we will write it. Why? Because x is equal to 5 if we take 25 is less than 25 is meaningless. That is the reason A value will come like this. Next, B equal to x is x belongs to n. 10x is less than or equal to 20. X is equal to 1 if we substitute, 10 will come. Next, x is equal to 2, substitute, 20 will come. More than we cannot write. So, A union B we can write it as A union B. So, 5, 10, 15 and 20. So, how can we write as a set builder form? This is, we can write it as x such that 5 is less than or equal to 5x less than or equal to 20. Am I right? See, if we take and x belongs to, one more information, and x belongs to n. See, x is equal to 1, substitute 5 will come. 5 is less than 20 or equal to 5 also. X is equal to 2 if you take 10, 10 is less than or equal to 20. X is equal to 3 also if you take, it comes. X is equal to 4 also. X is equal to 5 we cannot take till x is equal to 4 only. I hope you understand, students. This is set builder form by using. Okay. Now we'll write some notes based on that concepts note. So what are the notes regarding A union B? If A is subset of B, then that means A is subset of B means what? A is completely lying in B. So A is subset. B is obviously superset. A is subset of B, then A union B is equal to B only. At the same time, so point number 2, A union universal set mu equal to. So one set and universal set, if you combine that, universal set only will come, no? And if we take the union of one set and non-empty set and null set, again you have to get it as only non-empty set. This is very important point. Third one, A union complement A dash or A complement. We can write like this also, dear students. A union A complement, which is equal to mu. A and the complement of A we can consider as universal set. We already discussed in the last classes about universal set. Okay, dear students, we'll move to another set of questions, another set of concepts. Which concepts completed? Union of sets completed. Next, intersection. This one completed, dear students. Now, intersection of two sets. So, how to define the intersection of sets? Here, particularly, I am mentioning two sets. No, that is the reason. Let A and B be two sets. Then the intersection of A and B, denoted by A and B denoted by A intersection B. This is the symbol, dear students. Is the set of all those elements which are common to both A and B. So what is the intersection of two sets? Means the set of all those elements which are common to both A and B sets. So how to denote? That is, we can denote like this, dear students. A intersection B is the notation for the intersection of two sets. Set of all X such that X belongs to A and X belongs to B. In case of A union B, what I said, X such that X belongs to A or X belongs to B. In case of union of two sets, intersection means and will come. That is the reason you remember this important point. Okay, dear students, let us consider some examples. Based on that, we will move that. The first one, let A equal to 1 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And B equal to 1, 3, 5, 7. Therefore, A intersection B. Observe carefully, dear students, whatever elements are common in A and B sets. 1 is common now, that you write it here. And 3 is common now. And 5 is also common. And 7 is also common. So, there is no other elements in common. So, your answer is A intersection B is equal to 1, 3, 5, 7. Absolutely, we can write as A intersection B as B also. But only in this case it is possible, not in other cases. Okay. Second example, let A be the set of all English alphabet and be the set of all consonants A intersection B is the set of all consonants, or set of all A intersection B is the set of all consonants in the English alphabets. Okay, dear students, English alphabet only it is. Okay, set of all English alphabets, B is only consonants. In all alphabets, consonants is common, no? That is the reason A intersection B is the set of all common consonants in the English alphabet. At the same time, another example with the mathematics, we can take it like not alphabets. Let E be the set of all even numbers, even natural numbers, set of all even natural numbers, and O be the set of all odd natural numbers. Set of all even natural numbers is equal to, even natural numbers means 2, 4, 6 and so on. O equal to all odd natural numbers 1, 3, 5 and so on. Is there any common elements in these two sets? By observing E intersection O equal to, no elements are common. Like this we can represent, or we can represent as 5, that is called null set, 0 set, null set, void set. Like this we can say that. We already discussed about this null set concept. Okay, dear students, I hope you understand. We'll move to some notes, important notes. So based on intersection also, the first point, if A and B are disjoint sets, then A intersection B is equal to 5. This is very, very important. If A and B are disjoint sets, then A intersection B equal to 5. That means there is no common elements in both the sets. For example, example 3 in the above, if you observe that E is set of all even numbers and O is set of all odd natural numbers, the intersection is null set, no? So E and O are said to be what? Disjoint sets. Okay, students, I hope you understand. Next, point number 2. Note. If A is subset of B, then A intersection B is equal to A. Here whichever the set is small, that only will come. Next, point number 3, A intersection universal set is equal to A. Why? Because universal set is superset of A. A is a non-empty set in that universal set. So A intersection universal set equal to A. And also A intersection null set is equal to null set. For every set, null set is common set. Okay. And next, another example. A intersection A complement, or we can write like this: A intersection A power C is also equal to 5. But A union means what? A union A dash, it will be equal to universal set, but intersection case is null set. Okay, dear students, we'll move to another concept. Difference of sets. In difference of sets, we have to consider two sets here also. Same thing. Let A and B be two sets. Then the difference of A minus B is the set of, then the difference A minus B is the set of all those elements which are in A but not in B. This is very, very important. Which are in A but not in B. See how to denote. That is, we can denote like this: A minus B is equal to set of all x such that x belongs to A, which are in A means x belongs to A, and x does not belongs to B. This is the definition of A minus B, dear students. For example, we'll consider some example. Let A equal to, numbers we can consider 3 multiples till 6. 3, 6, 9, 12, 15 and 18. Next, B multiples, B, and B equal to 2 multiples till 18, you can take it. So 2, 4, 6, 8, next 2 4s are 2 5s, next 10, 12, next 14 and 18. Okay, this is let A and B. In this, first we will find out A minus B, the elements which are present in A and not present in B. The elements which are in A means what? A is equal to, in that 3 is there in this, not there, so 3. 6 is there in A and B also, no, we cannot take. 9 we can consider yesterday, why? Because this is not there. 12 is also there, so 15 we cannot, 15. 18 is also there. So what are the elements we have? 3, 9, 15. Okay, dear students, A minus B means the elements which are present in A and not in B. So 3, it is in A and it is not in B. Similarly, 6 is there, but in A, in B also it is there, so we cannot take it. 9, it is there in A and but it is not in B. Similarly, 12 is in A and also in B, that's the reason we are not taking. So 15, it is also there in A but it is not there in the B, so we can consider like this. What about B minus A? B minus A means the element which belongs to A belongs to B and if it is not in A. So x is equal to 2, you take it. 2, it is not there in the set 3, so 2 we can write it. Even 4 is also not there. 6 is there in A also, so we cannot consider. 8, it is not there in A. 10 is also comes. Next 12, it won't come. 14, it is there in B, but it is not in the A. 18, it is there. So these are the elements of B minus A. I hope you understand the concept. A minus B and B minus C. If you want, we can write B minus A definition also. B minus A, what we can define? Here, note. B minus A equal to x such that x belongs to B and x does not belongs to A. Okay, dear students, this is about B minus A. Note number 1, that is note number 2. A minus B is not equal to B minus A. You observe that from this. Unless A is equal to B. Unless A equal. If A equal to B means A minus B and B minus A both are same. Okay, dear students. Point number 3, note number 3. For any set A complement or A dash is equal to mu minus A. Mu means universal set minus A. Okay, dear students, I hope you understand. We'll move to last concept, that is for the last concept, symmetric difference. Till now we discussed about these intersection of sets over, union sets over, difference of sets over. Next, symmetric difference. This is we are discussing. This is the last concept, dear students, in that. Symmetric difference of sets. Let A and B be two sets. Then the symmetric difference of A and B, denoted by A delta B, and is the set of all those elements which are either in A or in B but not in both. That is, so how can we write A delta B is equal to X such that X belongs to A and X does not belongs to B, or X does not belongs to A and X belongs to B. See, first definition, X belongs to A and X does not belongs to B, means it is indirectly the definition of A minus B only, no? Okay, X does not belongs to A and X belongs to B means it is indirectly B minus A only, no? So we can write it as, this is actual definition, will give us a note. A delta B is equal to A minus B, or means union B minus A. So that also we can write it as, even this also, A delta B in other terms, A union B minus A intersection B. So either this one or this one we can continue, dear students. A delta B, these are the more important points. Let us consider one example. Example based on that concept of symmetric difference. Let A equal to 1, 2, 4, 6, 8, 10 and 12, and B equal to 3, 6, 12. Then find the solution. A set is 1, 2, 4, 6, 8, 10, 12 and B is 3, 6, 12. Then find A delta B. For finding A delta B, we need to find A minus B and B minus A. So first A and B values we are going to write. A set is 1, 2, 4, 6, 8, 10, 12, and B set is 3, 6, 12. First find out A minus B. What is the definition of A minus B? The elements which are present in A and not present in B. So the elements which are belongs to A and not belongs to B. So 1, 2, 4, 6 is there in this, so no need to write. 8, 10 also we can write, but 12 no, we cannot write. Why? Because it is there in the B. Similarly, B minus A we can write it. So 3, it is not there in A, it is there in B. 6 is there, 12 is there in that, so we can write only singleton set. So the definition of A delta B is equal to A minus B union. Here two definitions are there. I will prove both the definitions. A minus B union B minus A. This is the first one. That is equal to A minus B, we got 1, 2, 4, 8, 10. Union B minus A means 3. So the combination of these two letters, A union B, means the elements which are in A and B and both in A and B. So 1, 2, 3, 4, 8, 10. Okay, dear students, this is about A delta B. Okay, I hope you understand. Method 2 will go A delta B, A union B, and this is method 1. Method 2. Method 2 means another definition we are going. So first find out A union B. A union B means 1, 2, 3, 4, next 6, 8, 10, 12. Next A intersection B. A intersection B means what are the common elements? 6 and 12 only, no. 6 and 12 are the common elements. 6 and 12. So A delta B, second definition, A union B minus A intersection B. So A delta B equal to A union B minus A intersection B. A union B, the elements which are A union B. So 1 is there. 2 is also there. 3, 4, 6 is there, we cannot write. 8, 10, that's all. So from both the method 1 and method 2, we got the same answer. I hope you understand about the symmetric difference A delta B, dear students. Okay. This is the way we can do that symmetric difference. In the next video, we'll come with some important results. After that, Venn diagrams also will be there in another video. Okay. Yeah, thank you for watching our channel Maths with Panindra.